All right, so this is exercise 13C, question 5A. So I'm going to really approach this question in two different ways so we really get a full picture of what's going on. And the rest of the questions that I go through in this topic are going to be more straight to the point. But this one, I really want to take my time and really make sure you understand what you're doing. So let's begin by reading the question. What do we need to do? We need to sketch the graphs of the following functions, give equations of asymptotes, we need to give the y-intercepts, and we need to give the range. The x-axis intercepts need not be given. I love how they've written that. It need not be given. Okay, so this is what we've been given in A. F of x equals 3 multiplied by 2 raised to the power of x plus 2. Now, the way that you should think about this is that we've been given this, which has been obtained by transforming the graph of y equals 2 raised to the x. So y equals 2 raised to the x is your parent graph. We have applied some transformations to it, which has given us this. So let's now consider what our parent graph looks like. So I've drawn down here y equals 2 raised to the power of x. Now, what are some two key features that we know about all exponential graphs in this form? The first one is that they all share the same y-intercept, which is 0, 1. The other thing that we know about them is that they have the same asymptote. They have the asymptote of y equals 0. So right here, I'm drawing it in. This is y equals 0. Perfect. So this is what we're starting with, and now we're applying some transformations. The first transformation is, let me grab my pen, we have this 3 multiplied. What's that doing? Well, that's a dilation by a factor of 3 from the x-axis. So I can actually show you something really cool right now. I'm going to take my graph and I'm going to dilate it from the x-axis. So in other words, I'm going to stretch it from the x-axis. So ready? I'm stretching it from the x-axis. And as you can see, as I did that, my y-intercept changed. I now have a new y-intercept. So let's really reflect on what's going on here. So I started with 0, 1 as my y-intercept. I then dilated it by a factor of 3 from the x-axis, and it changed my y-intercept. Now, the way in which it changed my y-intercept is that it let me do this in a different color. Let me do this. It multiplied it by 3. So that means what I'm getting now is 0. 1 times 3 is 3. So let me come over here now. Let me grab that. Let me put that over there. Let me come over here. Whoops. Let me come over here now. Let me click off that. Let me come over here. So this is 0, 3. But we're not done yet. We now need to consider the fact that we have another transformation, which is this plus 2. What's this plus 2 doing? Well, it's followed by a translation of 2 units in the positive y direction. So in other words, I'm translating it 2 units up. So now what I'm going to do is I'm going to grab my graph and I'm going to move it 1, 2 units up. But also remember that that's going to mean that my asymptote is going to change. My asymptote is going to obviously follow it along, so it's going to go 2 units up as well. Well, if my asymptote goes 2 units up and it started at 0, that means it's going to be y equals, wait for it, 2. And it also means, as you can see, I have a new y-intercept. So right there, it should probably be a bit higher. So let me just quickly do some alterations. Whoops. This is not to scale. So y equals 2, it should be a bit more above, shouldn't it? It should be between that 3 and that should be like here. So let's pretend that's perfect. Okay, so that's what it's going to be. Now we need to find what my new y-intercept is going to be. So I've moved it 2 up. So as you can guess, what's going to be is I'm going to plus 2. So I'm going to get 0, 5. So this is going to be 0, 5. Perfect. And just like that, we've found what my new y-intercept is going to be. So you can see we kind of did this conceptually, what's going on here. But obviously, when you're in the test or when you're doing your exercises, you're not going to have a literal parent graph that you can stretch and move. You're going to have to work from scratch. So let's do that right now. So this is going to be painful for me and you. Let's rub out everything we have here. Let's rub it all out. Whoops. Actually, it's probably a better way to do this. Let me do that. delete. Let me do that, delete, delete, and I'm going to get rid of that as well. I know that was painful. It was painful for me too. But when you're in a test, you're not going to have that to a parent graph. You're going to have to go from scratch and you're going to have to figure it out. Well, I'm going to look at this and I'm going to say, well, I have this plus 2. That means I'm going to have a y-intercept of y equals 2. The next thing that I'm going to have to find is what my y-intercept, I'm going to have a y-asymptote of y equals 2. Y-asymptote of y equals 2. Now I'm going to have to figure out what my y-intercept is going to be and how this 3 is going to affect it. You obviously can't really draw a dilation of a factor of 3. You can't really represent that by drawing it. But the way that it is represented is by what your y-intercept is going to be. It's going to change it. So to find what your y-intercept is going to be, you're going to say to find y-int, let x equal 0. So to find the y-intercept, let x equal 0. So it's going to be y equals 3 multiplied by 2. And instead of putting this x, I'm going to put a 0. Then I'm going to plus 2. This is going to be y equals 3 multiplied by 1 plus 2, which is going to be y equals 3 plus 2, which is going to be y equals 5. And that's exactly what we found before. So if I come now and I draw this, I know that my y-intercept is going to be 0, 5. Because this is 5, that's what we found here as well. Everything checks out. But remember, using this technique is how you're going to use it, how you're going to go forward moving on. You're going to use this approach. Now, what is my asymptote going to be? Well, my asymptote is really easy to find. It's simply going to be y equals 2, which I got by that. So y equals 2. What is my y-intercept going to be? Well, we found that by using this technique, which is 0, 5. And finally, we need to write down what my range is going to be. And my range is simply going to be, well, it's all my y values. I'm going to start at 2, not including it, and go all the way to infinity. So you can think of it here, it's like this. I'm starting at 2, not including it because that's an asymptote, and then it's going up, 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 all the way to infinity. And that's because that exponential keeps on going up and up and up. And just like that, I've answered this question, and this has really been a longer video than all the other videos after this. And all the other videos, I don't go through this much explanation, but for this first one, I really just wanted you to understand what's going on. So hopefully this has been helpful.